Hello and welcome to the tutorial for the software IBP 18599. In this video, you will learn how to get started with the software and learn the basics. We will start by creating a new project. The new project window will appear automatically when you start the software. Here we can create a new project. We will name the project to Introduction Project. The type of the building will be non-residential, and we use only the wizard in the HVAC wizard settings. Finally, we click on the OK button. The first window we see is the project node. This is where we can enter all the relevant data for the project. Next to this is the Project Images tab. Here we can add drawings, photos, or anything else that is useful for the understanding of the project. Next, we move on to the Building node. In this node, we can add a variety of data. Let us start with the Building Data tab, which is already open. We start by changing the name of the building to Example Building. The building category is set to Office Building, and the thermal bridges will be as they are right now, not in accordance with recommend solutions. The construction weight will be medium, and the location of the building is moderately open. Last but not least, the condition of the building is normal. Next, we define the number of floors of our building that are heated and cooled. We enter the value 3. In the next section, Building Automation, we select level C for our systems. This is the default level, and as we do not have any further information, we will use this level. Now we move on to the Construction tab. This tab allows us to create constructions that we can use later when we create the building envelope. Here we want to create 4 constructions. We will start with the external wall construction. To start, we click on the Add Construction button. A new construction will appear in the list. First, we click on the details of the selected construction. We will name this construction to External Wall. The heat flow direction is already correct, and we can leave it as it is. Next, we go to the Layers tab. Here, we add a new layer using the Add Layer button. Then click on the empty Name drop-down menu. There we will be able to search for the material that we want our wall to be made of. Our first material will be plaster. Therefore, we enter plaster. Then we click here on cement plaster. As soon as we have added it, we need to give it a thickness so that it contributes to the calculation of the U value. Here we change the thickness to 1 centimeter. Note that the material at the top is the inside of the construction, as we can see here with the RSI value. The bottom element is the outside, as we can see here with the RSE value. The next material will be concrete with a thickness of 20 centimeters. Here we select concrete with 2,200 kilograms per cubic meters. The thickness of this is 20 centimeters. After that, we add a layer of EPS insulation with 12 centimeter thickness. We select expanded polystyrene EPS with 30 kilograms per cubic meters and a thermal conductivity of 0.035. Last but not least, we enter the 12 centimeters of thickness. Gypsum plaster, 1.5 centimeter thick, will be the last layer. If we want to define our own material, we can click on the button Add User Defined Materials. The properties are the name, the category, for example, thermal insulation materials, and the thermal conductivity and raw density. It is also possible to define the water vapor diffusion resistance value if required. Click OK and close the window. When we are finished with the layers, we can go to the Visualization tab. Here you can see the construction with its layers as a drawing. Then we add the next construction, the roof. We click on the Add Construction button again and go to the Details of the selected construction tab. We name this construction Roof. We also change the direction of the heat flow to up. This time we are going to use the Enter U value directly checkbox. With this option enabled, we can enter a U value for the construction directly without adding layers. We enter the value 0.35 here. For the ground plate and the entrance door, we use the same approach. The ground plate has a U value of 0.4. The entrance door gets the value 2.9. What we've forgotten is that the ground plate doesn't have the heat flow direction horizontal, but it has down to the ground, since below the ground plate the soil starts. Once we checked everything and set everything to the right properties, we can continue with the Windows tab. Click on Add Window. Then we can give the window a new name. We call it Double Glazed Window. Then we change the glazing to double insulating glass with single airspace. The frame to PVC 3-chamber. And the spacer we change to PVC. We will leave the rest of it as it is. Then we click on OK. Now we move to the building envelope node, which we can see here. This is where we are going to add all construction elements of our building. We will start with the external walls for each orientation. The orientations that we have are north, east, south, and west. First, we click on the Add a Wall or Vertical Element button. Then we click on Add a Wall to the outside. After that, we will change the name of the wall to North External Wall. The type of the element is already the right one, external wall. Next, we choose the construction. Here we can select the construction external wall, which we created earlier. The orientation is set to north. The angle of inclination is set to 90 degrees because it is a horizontal element. For the envelope area, we set the value to 50. The next walls we will create in the same way, except that we will have different orientations. In order to accelerate the process, we can copy the already created current wall. Now we only have to go to each wall, rename it, and give it another orientation. Now we are done with the walls. Let's add a roof. For that, we click Add Roof or Upper Element. Then we click on the element and rename it to Roof. The type of the element is already correct, flat roof. Then we assign the construction roof to it. And we set the area of the roof to 150 square meters. Similarly, we create a ground plate by using the Add Lower Completion button. Then we click on the element, rename it to ground plate. Type of the element is already correct. And then we assign the construction to it, which is here ground plate. Then we also entered the value of 150 square meters. Finally, we will add windows to our building. For that, we have two approaches. The first one is by clicking on Add Transparent Element and selecting Add Window. As soon as we add the window, a red error message appears in the top left corner. This is an easy error to fix as there is no element type assigned to the newly created window. Once we add our window construction, the error message goes away. The purpose of this is to ensure that the window is given a type, as there is no way to enter a U value directly. We set the orientation for the newly created window to north. The area we changed to 6.5 square meters. Then we assigned the window to the north wall. To do this, we click on the north external wall, and then we can see here in the assigned components that we are able to select our new window. We click on it, and then we will have the window assigned to the north wall. Another way to add a window to a wall is to first click on the desired wall, then click on Add Transparent Wall. Then click on Add Transparent Element and select Add Window as a part of the facade. Now all we need to do is to specify the area of the window and type. As we did with the second window, we will add the windows for the left exterior walls. Once we completed this, we will continue with the zones node. For each area with the same activity and conditions, we create a zone. In our building, we will have 4 zones. Therefore, we click 4 times on the button Add a zone with a non-residential use. Then we will go to each of the zones and change the settings for them. Let us go to the first zone. We want this zone to be the office zone. Therefore, we change the name of this zone to Office Zone. The user profile is already correct. The net floor area is 527.04 and the net volume is 1570.58 and the total volume is 1791.94 cubic meters. The ventilation is a mechanical ventilation system, and we also activate the cooling. Then we click on the lighting node and create a new lighting domain. We change the type of luminaire to LED. Later we will do the same for the following zones as shown here. Once all the settings are done for the zone, we can go to the result for this zone node. Here we can see the energy demand for the zone. We can see that the highest energy demand is in the month January. Let us continue with the next zone. We will rename Zone 2 to Corridor. We change the user profile to Passageways Low Heating. The net floor area is 201.81 square meters. The net volume is 601.39 cubic meters. And the total volume is 686.15 cubic meters. This zone will be also ventilated with mechanical ventilation, and we will also enable cooling. Then we go to the lighting node and do also here the same as we did in the previous zone. Then we go to the third zone. This we will call toilets. The user profile for this zone is WC and sanitary rooms. Again, we go to the lighting node and then change the settings here as we did before. The entrance hall is then our last zone. It has the user profile passageway slow heated and has a net area of 29.38 square meters. The net volume is 87.55 cubic meters and the total volume is 99.89 cubic meters. Once again, we go to the lighting node and change the settings here. Now we have completed our zoning. Next, we look at the hot water demand node. For that, we click on a DHW demand. Then we click on Add DHW demand and we change the profile to Office Building. The tabs for these buildings are in the zone of the toilets. We now come to the HVAC Wizard node. Here we could select the Wizard only option if not done, but we decided to select this option at the beginning of our project. If we would have selected something else, we could change it here. The first system we define is the heat generation system. From the drop-down menu, we select a low temperature boiler. The heating emissions, we will keep the default value radiators. The hot water system will be a central in combination with space heating. Our energy carrier will be oil. We do not choose the solar thermal systems since this is not a part of our example building. As to the ventilation system, we also use the default value here. For the cooling system, we use the split multi-split option. Last but not least, we choose a small PV system. We click here on the drop-down and select small PV system. For each system, we get the efficiency for emission and control, distribution, storage, and generations. This can be seen in the right result window here. We have the efficiency for heating, DHW demand, and cooling. In order to set up a PV system, we need to go to the renewable power node. There we can choose to create a PV generator or a wind energy plant. As we can see here, a new PV system was already added. Then we click on this system and rename it to Small PV System. We will then go to the new node called Small PV System. Here we select the calculation based on collector area option. We will take 15 square meters as the total collector area without the frame. This we will change to 2023. Then we switch to the results for the whole building node. Here we can see the energy demand per month for the different HVAC systems such as heating. The lighter columns are the values for the notional building. This notional building is compared to our building to determine the EPC class, which we can see here below. If we want to see other energy types, such as primary energy, we can go to the drop-down menu at the top and change the value to primary energy. Now we see that our energy is changed to primary energy. Then we can see the month with the highest heating demand is January, and the month with the highest cooling demand is July. A complete overview of our building is given in the bottom window, which shows the total energy for all types. We see energy need, delivered energy, and the primary energy. If you would like to have more information of our building, we could choose the transmission heat losses tab, for example, or we could also choose the heat balance tab and also the emissions tab. The next step would be the EPC of the building, but this is shown in a separate video. This brings us to the end of this tutorial. In this video, you have learned how to enter a complete non-residential building. We started by creating the structures, moved on to the building envelope, and divided our building into zones. We then set up a hot water demand and used the HVAC wizard to set up all the necessary HVAC systems. After that, a small photovoltaic system is installed. Then we looked at the results. I hope you enjoyed the video. Thanks for watching and see you next time.